Hello students, so this is the second video on logarithm differentiation. If you have not watched the first one, so kindly go to my channel. You will find the logarithm differentiation part 1. Kindly watch that video if you have not watched the first part of this video. And in this particular video we will continue the solving of problems. Till now we have solved till 7 questions regarding this logarithm differentiation. Now we'll proceed further to solve some more questions of differentiation by using logarithm properties. So shall start. So the question number 8. The question number 8 says that if y to the power x equals to e to the power y minus x, then show that dy by dx equals to 1 plus log y whole square divided by log y. So let us start solving the question. So this is given to you, it's that y to the power x equals to e to the power y minus x. So here first of all what we'll do, we'll take log to the both side. So taking logarithm both side with base e. Okay, so if you take the log, you will get log of y to the power x equals to log of e to the power y minus x. So we know that by the property of the log that power comes in front, so it becomes x log y equals to, here the power is y minus x and this side will be log e. Now one thing you will remember that always the value of log e is 1 because we have taken the log with respect to base e. So the value of log e will always equals to 1. So we'll include that value here, that is x log y equals to y minus x into log e value is 1. So finally we get x log y equals to y minus x. Clear? Now we'll differentiate this equation number 1 with respect to x. So now differentiating both sides with respect to x. So the equation number 1, ddx of x log y equals to ddx of y minus x. So now for this side we can see that there is x, there is log y, and they are in the form of multiplication. So we'll use here rule of multiplication, that is at a time only one function will be differentiate and another one will remain out of the derivative, plus interchange them ddx of x. And this side the normal differentiation, that means first of all we will differentiate y and then we will differentiate x. Now ddx of log y is 1 by y and this is not same, so that's why dy by dx, plus log y ddx of x is 1, dy by dx and ddx of x is 1. So now we'll take all the dy by dx term to one side and non dy by dx term to another side. So first of all here x into 1 by y, that is x by y dy by dx, and taking this term from that side to this side, that is minus dy by dx equals to, this is minus 1 minus log y. So now they're taking common here dy by dx, we get x by y minus 1, and here taking minus sign common in between of them, we get 1 plus log y. Now let us take a LCM here, that is dy by dx, we take the LCM y, so we get here x minus y and this side minus 1 plus log y. Clear? Okay, so by taking the common of dy by dx, we got x by y minus 1 equals to minus 1 plus log y. So let us name this equation as 2. So now we go back to the equation number 1. Using the equation number 1, so from equation number 1, x log y equals to y minus x, and this was our equation number 2. So what we'll do basically, from equation number 1, from this particular equation, we are going to find the value of x by y. This factor value we will going to find by using the equation number 1. So let us try to find that. First of all, take all the x term to one side, that is x log y plus x equals to y, taking the minus x to this side. Now taking the x common, it is 1 plus log y equals to y. Now if this 1 plus log y shifted to that side, that is 1 by 1 plus log y, just cross multiplication. And now taking this y to cross multiplication to left hand side, just shifting to this side, we get x by y equals to 1 by 1 plus log y. So we got the value of x by y, that is 1 by 1 plus log y. Now we'll put this value of x by y in our equation number 2. Okay, so this is equation number 2. Now we're going to put the value of x by y. Now putting the value of x by y, we get 1 by 1 plus log y minus 1 equals to minus 1 plus log y. Now we take the LCM in left hand side. 1 plus 1 log of y, it is, by taking the LCM we'll get here 1 minus, and this side here it will going to multiply and give this side will be remain same, the right hand side part. Now after simplification in the bracket term, we will get here, if you open the bracket you will find that 1 will cancel, and minus plus minus of log y by 1 plus log y, and this side minus 1 plus log y. Now here the minus sign cancel. Then now do just cross multiplication, that is dd, 1 minute, it was dy by dx. I just forgot to write that. Yeah, it was dy by dx. So now just doing the cross multiplication, 1 plus log y whole square, and this side it is log y. So this is the proved. So thing is that whenever the question demands for finding dy by dx, you can simply differentiate, and whatever the answer you get, you can leave up to that. No more simplification required. But the thing is that when the question came like that, suppose an equation is given to you and you have to prove that for example, that this question, that's question number 8, here you have to prove this expression. So for that particular case, you have to simplify, or you have to reuse your given expression to prove the required dy by dx expression. So you have to learn both the techniques when you have to simplify the questions, or for when you have to prove some equations. So this is all about the question number 8. Now a similar type question to question number 8, that is a question number 9, and that will be a homework for you. Okay, so these are the two questions. Question number 9 is a ditto similar to question number 8, just a simple change in the expressions, otherwise it is totally the same question, as well as the question number 10 also is same. In question number 10, just you have to take the log, and remember one thing, the value of log e is 1, and then you have to prove this. Try these two questions. Information on thing I have to say that regarding my all the videos, previously all the videos, if I talk about the homework part which I have given to you, as expected, I know that will be happen only. It's just, if I say more or less total 10 students out of you, all the students, just 10 students response to that homework. Don't worry, I won't repeat this topic further after reopening the colleges. So I won't repeat any topic which I am giving lectures now, which I am teaching now. Not a single topic I will repeat that in that time. As well as you also come to know that your exam days are coming very close. So now it is your responsibility to study Okay, so now let us proceed to question number 11. Okay, question number 11 is if a to the power x plus x to the power y equals to 4, then find dy by dx. So in this question we can't directly take the log, because if I suppose the thing is that first question comes in your mind that let us take the log, come take the power down. So what the scene will be here? Roughly I'm saying taking the log, this side log. After that we cannot proceed, but because there is no such property for log a plus b has been defined till now. There is no such property. So we cannot split this thing whenever a plus b. So we cannot use the log directly here. There is a property that is which we know, that is log of a into b. Whenever that is equals to log of a plus log of b. That is the property. But there is no such property that log a plus b. So we cannot use here log. So what we'll do basically here, we will differentiate it separately. How? Very simple. We will assume that let u equals to a to the power x and v equals to x to the power y. And for that we will find here du by dx. For this we will find dv by dx, and then we'll put the here and we get our answer. So let's start the solution. Then the given question will form in this way: a to the power x is your u plus v to the power x to the power y is your v equals to 4. And therefore if you differentiate this, that is if you differentiate this expression, we get here for u it will gives du by dx, for v it gives dv by dx, and ddx of this side 4, and 4 is a constant, and we know that constant derivative is zero. So we will name this expression as 1. So from this u we will find our du by dx, we will put it here. From here we will find our dv by dx, we will put it here in expression number 1, and we will get our dy by dx. So let's start. So what was the u? U is a to the power x. So what is du by dx? We know this is a direct formula for this, that is ddx of a to the power x. The formula is, write it here, a to the power x log of a. So this is our du by dx. So we got our du by dx. So now we will find our dv by dx. Okay, so what was our dv by dx? Our v was x to the power y. Now let us first of all, there is a power, so we can first of all take log, that is log v, and this side log x to the power y, that is log of v. In this side power will come in front, that is y log x. Now we'll differentiate both sides with respect to x. Okay, after that, now ddx of log v is, for log v the differentiation is 1 by v. These two are not same, so this is dv by dx. And there are y into log x, two function, that is product rule, that is y ddx of log x plus log x dy by dx. So then 1 by v dv by dx equals to ddx of log x is 1 by x plus log x dy by dx. So finally your dv by dx is v into y by x plus log x dy by dx. So then putting the value of v, okay, then after putting the value of v, we will get dv by dx equals to, v value was x to the power y by x plus log x dy by dx. So we got dv by dx, we got dv by dx. Now we'll put the two values in this expression. So from equation number 1, du by dx plus dv by dx equals to 0. Now putting the value of du by dx is a to the power x log of a, and dv by dx value is x to the power y plus y by x plus log x dy by dx equals to 0. Now from here we have to find dy by dx. So first of all, let us open the bracket by multiplying x to the power y into y by x plus x to the power y log x dy by dx equals to 0. Now taking the dy by dx term to that side, we will get a to the power x log x plus x to the power y into y divided by x equals to minus x to the power y log x dy by dx. Just we need dy by dx, so we will take all the term to this side. So finally dy by dx equals to a to the power x log x plus x to the power y by x minus x to the power y log x, and this minus comes here, that means we can write this minus to that side also, and simply this is our answer. Okay, as just here I have to find dy by dx, so I didn't simplify this factor, I just left it in this form. But if it comes in a form of a proof, then you have to prove according to the question. Clear? So now we'll proceed to the question number 12. Okay, the question number 12 is, if x to the power y equals to y to the power x, then find dy by dx. Very simple question. Simply take the log, you will find your dy by dx. Let's start. Given x to the power y equals to y to the power x, then you have to write this thing, taking logarithm both side with base e. I'm not writing, just for the space you have to mention that line. So just taking both side log. Now by the log property, the power comes in front. Now differentiating both sides with respect to x, and differentiating this, that is ddx of y log x equals to ddx of x log y. So after differentiating, there is product rule here, y ddx of log x equals to plus log x dy by dx, and for that side x ddx of log y plus log y ddx of x. So this side y ddx of log x is 1 by x plus log x dy by dx equals to log y derivative is 1 by y, and this is y, this is x, these two are not same, so we will write dy by dx plus log y, and ddx of x is 1. So now simply we will take all dy by dx term to one side, so that is log x dy by dx minus x into 1 by y, that is x by y dy by dx equals to, and that's a log y into 1 log y minus for this term y into 1 by x, that is y by x. This is positive. From this side, if it goes to that side, it becomes negative. Now taking common, dy by dx common, that is log x minus x by y, and that side log y minus y by x. What we required? Just we require dy by dx. So what we'll do, we will take this bracket term. This is in the form of multiplication. If it goes to that side, it'll become in division. So finally your dy by dx is log y minus y by x, and here what was log x minus x by y. Now here you can simplify further, that is here you can take the LCM in numerator as well as denominator, then simplify. You can do that also. You can left up to this also. This all are correct. Okay, so this is all about for question number 12. Clear? Very simple question. So let us proceed to the question number 13. Okay, so question number 13. If x to the power y into y to the power x equals to 1, then find dy by dx. It is totally similar to question number 12. You will see how. See what is given here. I will just give the hint. You have to solve the question. X to the power y into y to the power x equals to 1. Okay. Very fine. Let us take one term from this side to that side. So that will become 1 by y to the power x. Now we know very well that from a term from denominator, if goes to numerator, the power becomes negative y to the power minus x. So this is your simplified form of the given question. So now you can take the log to both sides, then differentiate as the same question as a question number 12. Simply differentiate as a previous one. You will find your dy by dx. So this is the homework. So till now total 3 questions are homework for you. Okay, so question number 14. Question number 14 is, if x to the power y plus y to the power x equals to 1, then find dy by dx. This is also similar to that question number 12 as well as question number 13. See how. So first of all, same logic of question number 11, that we cannot take directly log here, because why? There is a plus sign. So what we'll do, we will simply assume, like I am also giving the hint for this one also. You will take let u equals to x to the power y and v equals to y to the power x. So then your given expression will convert in the form of u plus v equals to 1. Therefore, if you differentiate this expression, differentiation of u is du by dx, differentiation of v is dv by dx, and differentiation of 1 is a constant number, and constant number derivative is 0. You will name this expression as 1. Now from u, that is equals to x to the power y, you will find du by dx, you will put it here. From v, that is y to the power x, you will find dv by dx, you will put it here. Then from that expression, you will find your dy by dx. So try this question also. Question number 14. So again a new bonus question for you. You can see the question, if y to the power x to the power x to the power x up to infinity, then show that x dy by dx equals to y square by 1 minus y log x. And this is a result of the previous bonus question, BBA second sem and separately BCom fourth sem. You can see the name of the students who has responded at the earliest with the correct answer. This is a result of the previous bonus question. And the student, one more thing I have to mention, that in the previous logarithm differentiation video, I have given 3 questions as a homework to you, and that homework's result you will find in the description part of that particular video. So kindly check again logarithm differentiation part 1, that video. In that video, in the description part, you will find your homework's solutions. So for your answer, that answer is correct or not, for that just kindly check the descriptions again. And for Today there are total 4 questions as a homework and one more bonus question. Try to solve that and again send me the bonus question at the earliest. Okay, so this is all about for today in this video. In the next video we will proceed with further more questions on the basis of logarithm differentiation. Thank you.